Hello guys, welcome you all for this end-to-end session on AML where you guys gonna learn everything in order to become a successful data scientist. Hope you guys are enjoying this session. We are enjoying a lot and we are learning every day new thing. So yeah, actually as mentioned in the previous session we have completed a module, we can say, okay, working with data we have completed, okay. So we are now jumped into the concept of machine learning where we're gonna learn the theory concept as well as the coding part. So it's gonna be very interesting, guys. You're gonna learn the back box behind each and every algorithm in machine learning together with script coding. Okay. So in the previous session, we have just introduced you what is machine learning and the types of it. Today we're gonna continue that. So before going for this session, please make sure that you guys have watched all the previous session videos so that you can have a better understanding of what we are doing now. Okay. So yeah, without even wasting any time, just jump into this session. So today we're gonna first see about reinforcement learning. I think in the previous session we have done with two different types of machine learning, right? Supervised, where we will be giving a labeled data for the machine to learn. Unsupervised learning, we will be giving the unlabeled data for the machine to learn. Now, reinforcement learning is another type of machine learning technique, guys. Okay, so I hope this is gonna be somewhat tricky. I will say it is challenge to understand, but like just understand this. Okay, let's see. Let us do one thing. Okay, reinforcement learning, consider it's a game. Okay, I hope like everyone has played the game. Okay, now consider you are playing game for the first time and you are getting out the first time due to some kind of obstacle. Okay, you will be very sure for the next time if you hit on the obstacle you're gonna be out, so you will have some kind of consciousness, so you will not do that again. Okay, but you will face other obstacle, that's different thing. So like that. So what this reinforcement learning means, there will be a agent, guy. Okay, there will be a agent. Okay, it will act upon the environment. Based on its action it will get the reward or punishment, and it will go to the end. Okay, I will put it in a simple example. Okay, we all have played the Super Mario game. I think everyone know about Mario game, right? There is a character who is gonna hit the brick and it will collect the coin, like that it will do. Okay, I hope everyone know. Okay, so what is an agent? So agent is a learning system that interact with the environment. Environment, the context in which the agent operates. Reward, feedback signal that guide the agent's learning. Policy, the strategy that the agent uses to choose actions based on its experience. Okay, now I'm gonna put this to the game of Mario. Okay, there is a character. We have a small character, right? That is called as agent. Okay, the complete environment we are having, the agent will be moving, right? That is called as an environment. Okay, now we are fixing the agent and then environment. Now what's the reward? I think the agent, right, if it is move up, right, and breaks the big, it will get coins. Okay, that is a reward for its correct action. If it is do a wrong action, that if it is breaking a wrong brick, it gonna get some mushroom kind of thing which will hurt it. Okay, hurt the agent. So that is the wrong action, so it is getting the punishment for it. And that is called as a reward. Either it is a coin, that is a good action. For a bad action or a wrong answer, it is gonna get the punishment, like a mushroom. Okay, it will hurt the agent. That is what a reward. And once it is done, we will create a policy kind of thing, so that whenever you are getting some punishments, it will try to not repeat it, and we will go to the end goal. Okay, that is called as a policy. By using everything, it will create a policy to reach the final goal. Okay, hope I have just able to explain this by using a game. So in simple manner, an agent, what is reinforcement learning means, as a definition, an agent acts upon the environment. Based on its action it gonna get either a punishment or a reward based on some kind of set of policies. That's it. Okay, just look into, there is something called as a Super Mario game whenever there is a reinforcement. Okay, so yeah, sir, over to you. Yeah, so yeah, I hope like you guys can able to understand reinforcement learning, right? So reinforcement learning is something like you are just making agent to learn. Okay, the agent itself just understand the environment. Based on the environment action, it is able to react to it. Based on the reaction, it is getting the punishment or reward. Okay, hope it is you guys are able to understand this. Okay, so yes sir, is there anything that you need to add for this? Yeah,
Yes.
yeah,
So reinforced learning, guys, it is a very simple concept. And when you keep things simple, you understand and apply simply, and you get results. So, agent, what is agent? If we see in AI, ML, or machine learning, agent is a learning system that interacts with the environment. See here, learning system which interacts with the environment. But agents, the ultimately, if you see, the agent is a solution for a problem, right? A robot which is cleaning my house, the environment is the rooms and the lobby, okay, and the robot is agent, and it the same agent can be a bot, chat bot, and the environment will be the NLP and the content into it, and you ask question, it will answer. So it varies according to the objective function, guys. Agent is a learning system that interacts with the environment. So be very clear here. The environment as per the problem statement and the objective function you want to solve. So it will vary. So there will be different agents, okay, according to your problem. It can be a physical robot, or it can be a application, or it can be a software or something. So environment is the context in which the agent operates. It's a context. Uh, it's a space given to agent where it operates, and it is specific, like specifically solving that particular problem. And that particular problem, like I gave example of a cleaning robot. Rooms, lobby, all those places are the environment for that, so that it can operate there. Okay. Then rewards. So when it cleans 100%, it will get reward. If it is not cleaning properly, it will get punishment. Right? So like you play games, you when you play good, you get the reward, you go ahead in the next level of the game. If you don't play well, you get degraded or you don't get promoted. Oh, this is the simple thing. Okay. Policy is a strategy that the agent uses to choose action based on its experience, and it keeps changing, guys. It keeps learning, experience keeps building up. This is how Go game, if you've seen, Lisa Doll was beaten by DeepMind because the DeepMind kept learning from the experience with Lisa Doll, and he was 17 times champion in Go. Chess is 9 cross 9, guys. But Go game is 19 cross 19. So understand, if you make all the moves, the entire atoms in the universe, still you can't finish the moves of chess. So understand the Go games 19 cross 19, how many billions of years it will take to go through all the moves. Understand this. So why I'm saying that here? Because policy is the strategy that the agent uses to choose action based on its experience, and experience with time it will improve, okay, because it will learn from the experience. That is why it is machine learning, guys. Let's go to the other section.
yeah, sure sir. So moving on, yeah. So we have completed the types of machine learning, guys. Okay, and I will just promise you guys, we're gonna see each and every type, supervised, unsupervised, reinforcement learning. We're gonna see the algorithms inside it together with its coding part. That is what our next goal. Okay, yeah. So let's see what are the applications of machine learning. These things we have already know about it. Healthcare, it will diagnose some diseases. Okay, proactive methods, and then discover of new drugs based on its combination, permutation combination based on historical data. Whereas for finance, it is able to perform some fraud detection, risk assessment, risk mitigation, like those things we can do. And for e-commerce, it will create a personalized recommendation. Now only we have seen an algorithm, right? I think in the previous session, like association rule. Okay, and targeted advertising, yeah, this is also some kind of recommendation system. Okay, yeah. For transportation, autonomous driving cars. Okay, driving. Okay, we are having self-driving cars, right? And traffic optimization. Okay, wherever the traffic is high, we can just allow them to go. Wherever the traffic is very less, we can hold them. So like that we can do. So these are some of the machine learning application. It is not restricted to air gas. It is just, I will say, 0.001% application we have just shown in this slide, because this slide or anything, it's gonna take more space. The space will be not enough for specifying what are the application the machine learning has. Okay, just we are just giving the random things. These are the applications that machine learning have. Okay, there are n number of applications and n number of industries are working uh, due to this machine learning. Okay, n number of industries are running. Okay, so yeah, that's all about the applications. Yes sir, over to you.
Yes, guys, we have reiterated a lot of times machine learning applications. There are n number of industries where you can, wherever data is generated, you can put an automation system, you can put an machine learning algorithm, you can build a robot, and there are n number of robots you can build, guys, as per the environment. Okay, as per the problem. Cleaning robots, transport robots, police robots, army robots, n number of robots, huh? Assisting robots, customer care support robots, uh, managing in hospitals, healthcare robots, lot of, like, as per the environment. Now you know what I'm talking about. Environment means as per the environment and the problems of its environment. So solving through those specific, then you can build or online applications, tools and stuff. So healthcare, disease diagnosis, drug recovery, proactive healthcare. Even in healthcare, there will be thousands of departments and thousands of applications, guys. I'm saying thousands, it would be depending on how many layers healthcare has. You can apply everywhere, automate. First stage is to automate, optimize through these applications and all. Then finance, in finance, n number of ways. Trade, trading, forex, cryptocurrency, lot of applications. E-commerce, personal recommendation system, okay, advertisement, target audience, lot of product design, how to design effective, how to um, design products what people want after collecting lot of data. Okay, sentiment analysis you can do, lot of reviews we get on e-commerce, so you can build something for that. Chatbots, customer care support, lot of things. Transport, automation, self-driving cars, traffic management system, traffic optimization, finding new ways, working on new ways to uh, design traffic systems. Lot of their urban cities have a lot of traffic problems now. Car was created as a solution for the humankind. Now it has become a problem, guys. Pollution. So we have to think out of box to create new kind of transports using AI, ML, data science, machine learning, guys. So think out of box, create new industries, because you are the data scientists, AI, ML engineers, AI scientists of the future. So learn deeply all these applications, Connect with us. Write us in the comment section what have you learned, how you're going to apply, what is your long-term objective function. Subscribe to our channels, press the bell icon so that you will get notification. Keep learning deeply, persistent, absorb the information, digest and apply and do all the assignments. If you have come here in this session, go and watch all the sessions 5 to 10 times, then and only watch this session. Keep learning deeply. Thanks.
Yeah. So these are the application, guys. So moving on. Yeah, challenges and limitations. Okay, whenever there is something is working good, there will be some challenges, right? There is some limitations. Okay, let's see. Data bias. That's the first challenge. Machine learning models can inherit bias present in the training data. This is why we guys are just mentioning, we just need to focus on where we are collecting the data and what kind of data we are having, how we collect the data, whether it's gonna have a bias or not. That's a major thing, guys. If you miss here, anything you do, you create a model, you deploy it, you go for prediction, nothing will work properly. Everything relies on the source and how you collect the data. So you should not have the bias in the data, so that only you can reach your end goal in a perfect manner. Okay, moving on. Security issue. Machine learning model can be vulnerable to attacks and manipulation. Now it is somewhat okay, but like if you're gonna deploy in some other platform, right, some other cloud platform, you need to just look into what are the things that how they are treating your data. Okay, whether they are a permission, they need a permission to read your data, whether they are maintaining your data, or whether they are periodically checking your data. Like that, you need to read through the documentation while you are deploying it to the cloud. But this security issue, it is not to the field of data science. Every field has this security issue, because like as sir is mentioned in one of the classes, so that only we are having cyber security specialist, okay, or analyst. Okay, so that's the reason we are having them. So security issue will be there, but like we need to safeguard our data as much as possible from our side, not as much as possible, to the extreme that we can do. Okay, then lack of explainability. It can be difficult to understand how a machine learning model makes decision. Okay, I will not like we will not accept this, because like we're gonna see the black box of it. But like to some point we can able to say, after that we are not able to say, because it's completely black box. we know the we know the theory of it, we're gonna learn the mathematics behind it, and we're gonna say this is how it's gonna work and this is how it is predicting, like that we can do. But there will be not 100% explainability. Okay, there will be some 0.01 or 1% of black box will be there after studying also. Okay, you need to have a conceptual understanding together with the mathematical understanding, so that you can able to explain it properly to the clients. Okay, finally, ethics concerns. The use of machine learning models or machine learning raise ethical consideration regarding privacy, fairness and accountability. That's true, guys. Okay, whenever data is thrown onto you, the major thing that a client or anyone who is giving you a data, right, they're gonna ask you for security and then ethics. So you need to consider the data as a what to say, it is a major thing for you in order to do everything, right? So you need to treat your data in a very safer manner, that it is not like being vulnerable or it is just leaking. No, 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 not kind of things. Okay, you need to have your data very very secure before you are going for analysis. So you need to have a proper cloud platform with more data security, or just sure, if you are not sure with it, just store it locally. Okay, have the data very secure. That is what everyone is expecting. Okay, before going for a visualization or kind of a insight providing, everyone is requiring you or any client, they need their data to be secure. Okay, so these are the challenges, guys. Okay, once we are just getting the project and going the things, you can get more challenges apart from this. But like try to just mitigate these challenges by different things that we gonna explain in the further sessions. So we will try to mitigate every challenges. Okay, so yeah, yes, over to you.
Yes. So, guys, challenges and limitations. So, data bias is humans are by nature biased. And telling on record, you keep it record with you. So, on record, I'm saying humans are by nature biased. There are very rare people who are not biased. Very rare. They will be saints. Okay. So now you can check how many saints are there in the world. So that is why if something is there, that's a big problem. This is a big challenge. So machine learning model can inherit biasness present in their data set. And guys, I would say there is no need of building any model if data is biased because then you know what you have given the input and what would be the output. You want to cheat, you want to create kind of uh, fraud with people, that's okay. If that is your objective function, but if it is genuinely helping people, solving problems, creating something valuable, creating some kind of revolution, value, innovation, then it should not be biased. Okay. Security risk. So machine learning models can be vulnerable to attacks and manipulation. Okay. And there would be companies right now, they would be running on machine learning, and if it is hacked, if it security is compromised, then the entire company can be in a big loss, and I think it can be destroyed because it's all about data. If that gets manipulated, your models, everything, so it is control. You lost the control, so it is gone. So you need to consider those things when you're making a pipeline or a project or a model or project, right? Lack of explainability. It can be difficult to understand how machine learning model can make decision. So that is why make it clear, make it a flow chart or a simple communication so that uh, it is explainable. Okay, so these are challenges. So make it simple. Okay, and this challenge will be mitigated, and then ethical concerns using machine learning, rising ethical consideration regarding privacy, fairness, and accountability. So these challenges needs to be opposite. You have to do opposite of it to mitigate them. Non-bias, security, data should be secure, you need to explain it well. Okay, ethically, everything should be considered in an ethical manner. Okay, no ethical or value should be compromised: integrity, privacy, fairness, accountability, and then that will make your project and you a great data scientist or AIML or AI researcher or AI scientist. Let's move to the other section.
Yeah, sure, sir. So moving on, yeah, what are the future trends we are having in machine learning? Okay, first is edge computing. I will not say future trend; it is from a present. Okay, they are happening in the present. Let's see what are the present trends and future in the machine learning. Edge computing, developing machine learning models on a device that at the edge of the network. Okay, edge computing. We can integrate this machine learning model there, and we can work on edges. Okay, next, explainable AI, XAA. So developing models that can provide transparent and interpretable explanation for their decision. Okay, I think this is an ongoing process. Whenever there is a decision happening, right? These are the steps that the model takes in order to make the decision. That is an happening thing. Okay, that is explainable AI. Okay, next is federated learning. So that is training models on decentralized data without sharing sensitive information. Yeah, this is also, I think, like guys, in this stage I will just explain a project which I have done. So it is like a, okay, I have created a chatbot. Okay, uh, it has a sensitive data. Okay, actually the company has shared me a collection of data in order to create a chatbot. So it has some sensitive information. I am creating a chatbot and I'm using a OpenAI. Okay, you guys know about ChatGPT, right? I'm just using that API to call in order to create the chatbot. I have the data set, okay, of the company they have given. I have created database out of it, and I have created chatbot using the ChatGPT API. Now, if a user converse it, it will just converse based on the knowledge base is gonna have. Okay, because like I have connected the API of ChatGPT with this data. Now, whenever we are asking the some questions, the ChatGPT will connect with the database and it will retrieve the answer and show to the user. Okay, but now the information is very sensitive. Okay, if I do this, the client will not accept because the data will be readable and knowable by the OpenAI, right? Because I'm using a ChatGPT API. What I have done means I have just duplicated everything. Okay, the sensitive information that I am having, right? The name, the company's name, the website name, their contact number, everything. I just anonymized it. Okay, I have given alternative numbers. Okay, whenever I am having phone numbers, it will be replicated by some other substitute numbers. Okay, name is there, some other substitute names, some kind of timings, ATM card numbers, like those things. I have substituted it and then I have just anonymized it. Okay, what I have done means I have the data with sensitive information. I have anonymized it and pass on to the LLM, that is OpenAI LLM. When I am chatting, okay, the LLM retrieve the anonymized content only. In my end, in a local end, I just re-anonymized it and show to the user. Now you guys can understand, right? Now ChatGPT has only anonymized data. It doesn't know the exact name, exact card number, everything. Okay, but when the user talks, right? When the client talks, they know exact answer because we have de-anonymized in a local space. Okay, while I'm just looking into this federated learning, I'm just explaining this project. So that's very important, guys. Okay, every client who are ask you to build some kind of application AML, they are just first thing they look into is how you gonna handle their sensitive data. Okay, that's a major thing. So next, quantum machine learning. So actually sir is explaining this every time in every section, at least a bit of it. Okay, I think sir can explain this more. So quantum machine learning, like harnessing the power of quantum computing to accelerate machine learning algorithms. Yeah, true. Combining this quantum computing with machine learning, we can expect like a huge revolution than now we are having today. Okay, so yeah guys, that's what about the future trends. I will say present plus future trends in machine learning. Yes sir, over to you.
Yes. So future trends in machine learning, edge computing is it's a reality right now. Deploying machine learning models on device that the edge of the network, at the edge of the network. So this is what is edge computing. Then we have explainable AI, developed developing models that can be provided transparent, interpretable exploration for their decisions. So this is what is explainable AI. Then we have federated learning, right? Federated learning, right?
Yeah, yes sir, yes sir, yeah,
Yeah.
yeah.
Training model on decentralized data without sharing sensitive information. This is like you have to feder means the control, like in a control manner, so that in a decentralized, like you have federal system, na. So the word federated is coming from the federal system, like decentralized way of governance, like federal system we have. So, so training model on decentralize that data without sharing the sensitive, always controlling the sensitive information. That is federated learning. Then you have quantum machine learning. So quantum machine learning is, guys, I'll give little explanation. Machine learning, normal machine learning is working on binary 0 and 1. So we have to make it so simple so that machine understands. That is the fundamental concept of a computer science. Okay. When it comes to quantum is it comes from the atomic structure, guys. Quantum. If you see there's a space in atom, there are quantas, and the word quantum comes from there. Okay, so quantum, what happens there is the normal computers, they are binary 0 and 1, but quantum computers are their basic fundamental unit is qubit. Qubit means quantum bit. Our computers is like bit. It works on bit, okay? Bits and bytes or whatever, right? But quantum computer works on qubits. So qubits are like they can, and see, your are right now the computers which we are using normally, they work on 0 and 1. Either they will be at a state of 0 or 1, right? But in quantum computers, in a like I'll say fraction, you make it 1,000 times, fraction of seconds, you make it million times, and that speed of light, let's say at the speed of light, qubit, it would be any position 360-degree. That's called superposition. For normal computers, when it comes computing, it will come 0 or 1, right? But quantum computers will do like, uh, they can do weather prediction for next 100 years. They can tell this region will become a drought or not. Healthcare, in manufacturing personalized medicine, guys. Right now we eat generalized medicines, like which is like done test on 10, 20,000 or 1 lakh people, and because of that we are eating medicine which is like, which will not be relevant according to your genes and your DNA, right? But imagine you have a personalized medicine for you which is only developed for you. Healthcare revolution will be there. So quantum computer trading, in suppose in market and stock market, you can predict for next 50 years what will happen to this stock. So should I invest or not? At a super fast level, I'll say speed of light level, you'll get, I'll say billions, no, trillions of data simulations can be done simultaneously. And quantum machine learning is a like simultaneous functioning happening the way universe functions. Like right now we are sitting in India, okay? In India, there's a specific time. Every state has a different time zone and there's different culture. A lot of things different. Event can happen in Delhi, in Chennai, in Pondicherry, in anywhere in the world. So in Japan, it will be some event. In America, something, something. So the kind of environment you have, the kind of space you have, each so how much data is generated per second. See, imagine Japan, America, all the world, the space we have, then this is Earth, then the entire universe, guys. And that kind of calculation, simultaneous calculation on which universe functions, quantum computers can do that. And quantum machine learning comes from that space, guys. So harnessing power of quantum computing, accelerating machine learning algorithm. And when quantum and machine learning is combined, there would be a real great magic so that we can manage uncertainty. Ultimately, guys, why we are learning AI/ML, why we are learning data science, why we want to learn quantum machine learning, why we want to create new innovation to manage uncertainty with probability, with stat, with data science, with algorithms, with data. Ultimately, to learn from the data and make solutions and predict the future. And quantum computer will do trillion times faster. In quantum machine learning, you can see, imagine only that what will be the world. If you guys have seen movie called Lucy, she uses 100% brain, and then that lady can see data everywhere in a flux, changing. She can see in everything as a data, tree as a data, sand as a data, stone as a data, air as a data, water as a data, space as a data, earth as a data, house as a data, human as a data, everything data. And it's like zoom, like you when you see binary matrix, if you have seen zoom numbers doing zoom kind of thing, so that lady can see that. So it's a frictional movie, but so, and I'll give you another insight. At quantum level of the fundamental level, that is the quantum level, where everything originates and diminishes. Everything originates, everything diminishes. So there's a continuous change happening. So at a quantum level, the way universe functions, so machine learning will go to that level. without doing meditation for 30, 40 years, machine learning go in a second's time into a quantum level and try to manipulate. See, understand and remember this word, guys. Manipulate at an atomic level and make the changes. Suppose when quantum computers will come, it will go to the atomic level. You don't need ACs. It will go to the atomic level of the air which is in your room. The drop the air, oxygen molecules, and it will go there and make them cool. You don't need AC. So that is quantum computing. But right now we need very, very low temperature places for quantum computers. Definitely we'll come up with quantum computers who will be temperature resistant. We can use everywhere. But uh, right now quantum computers need very low temperature places where they can be operationalized. So this is just a futuristic view, guys. Keep learning deeply, understand each and everything, watch all the sessions 5 to 10 times, do reinforced learning, absorb the information, digest the information, and apply to all the assignments, and keep learning deeply.
Yeah, guys. So actually, like, it's a great information that you have given related to quantum computing. Okay, today I have learned a lot from you, sir. So that's great. Yeah, guys. Like, this is what we gonna, as sir is mentioning, using data we gonna do the magic. Okay, we will do like this. Okay, everyone is expecting a data scientist to do a magic. Yeah, we will do a magic by using data that we are having.
And
Okay,
I'll add a
so
point. Data is
yeah.
life, guys. Today, while I was explaining this, so I see data as a life. So life is everything. So everybody wants life, right? So I think it is beyond economy and currency now. We've because see, when we do deliberation, so these sessions are like deliberation sessions. They are not monologues. One person is teaching only. So there are different perspectives. So I bring my experience, my way of learning. Raja brings his experience, his way of explanation. So this makes synthesis here. So this is a synthesis school. So different level of, so no YouTube channel will do this, and they never have imagined. We are, or any institute, no, so any academy will do this. So we are focusing on, we want to break all tradition. We are challenging status quo. Write in the comment section, give us feedback so that we can keep continuously improving. So we are open 360-degree for improvement. Okay. And so I was saying data is life. This is my final definition because it's everything, and life is everything, guys. If life is there, then and only we can find solutions and we have problems. So it's life. You need to understand life. If you understand data, data science, AI, ML, ultimately you are going to understand life. I learned a lot when 15 years ago I started learning books on AI. Okay, I started learning myself, and there at that point of time nobody was uh, people will say why you are learning this. I said you will get to know why I'm learning this. So I'm a very futuristic person. I can see ahead a lot. So 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 i um, i was learning, guys. I learned actually from where thought comes, and that I learned only doing research on AI. You can imagine. AI is not about coding. You will say, "Oh, I have to learn coding and all." It is computer science. It is economics. It is behavioral science. It is mathematics. It is human behavior. It is economy, game theory. It is psychology. It is ultimately, I'll tell you, it is life because from data you make models. Data is life. AI, ML is